Tigadan 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 pam pam tigadan 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 pam pam tigadan 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 pam pam tigadan.
All right, for our end note, we have Gregory Kurtzer from Control IQ, who's going to be talking about OS migration, roadmap, and features. Hi, Gregory.
Hi, can you hear me okay?
Yes, I can.
So thank you for having me. I'm here to talk a little bit about a number of things, starting off with Rocky. I'll give a little bit of background on what's happening with Rocky Linux, talk about the future of Rocky Linux and some migration. I'll talk about Apptaner, Werewolf, and then a big project, a really cool project that we're working on, which is called HPC 2.0. It's called that kind of tongue in cheek. But that's kind of high level view of what I'll be talking about. I'm going to start off with Rocky Linux. So first thing is Rocky Linux is designed to be a drop-in replacement for CentOS. It was fairly unfortunate when we got the news that CentOS was going to be going end of life. That affected us. It affected our customers, the community at large. I was in a good position to do something about it because I was one of the original founders of CentOS. So I did. I announced that CentOS EOL is highly unfortunate, but I'm going to be starting on a new project. Didn't have a name for it yet, called Rocky Linux. And within hours of posting that comment to the CentOS blog, it had literally thousands of people were joining the HPCNG community, which was the Slack that I asked people to join to because that's where I was hanging out at the time. And we got about 10,000 people joining roughly in about a month to 2 months. So it was quite a number of, quite a massive amount of uptake and interest from the community. The goals of Rocky Linux to be absolutely compatible, a drop-in bug-for-bug replacement or alternative to any of the operating systems within the enterprise Linux stack. Another goal is to be open source, and even more so than open source, be completely community controlled. And I can talk a little bit about that if there's questions about how we set that up or why we set this up. This is not something that I put into CIQ, my company. This is something that I kept outside of CIQ and kept it in the community because the last thing that we needed was another company controlling an open source project. So we did keep it outside of the company. And I'll talk a little bit about community on the next slide. But confidence in that open source project is so important. It's critical. And the way that we looked at it was you don't get absolute confidence in an open source project when you have a single company behind that open source project, even if that company is really big, as we've seen. What you get is to get confidence, you need many companies, many organizations, and many people all standing behind that project. And that was why we set up Rocky as we did. So again, community enterprise Linux alternative. It is bug for bug compatible with all of the enterprise Linux upstream variants. Our goal is to partner and work with every cloud, every OEM, every ISP. And the reason why is because that helps everyone. That sounded super cliche, sorry. And the name, just to touch on this is our most frequently asked question. Will we change the name? No, we are not going to change the name. The name actually is a hat tip to one of the original CentOS founders along with me, but he passed away right before releasing CentOS to the world, and he never got a chance to see how CentOS would absolutely change the world. So no, we are not renaming it. Rocky Maga is the developer that I'm talking about. He was a huge open source advocate, and he had a lot of friends within the open source community and high performance computing industry, which I'll talk about here in just a moment longer. But that's where the name Rocky Linux came from. All right, so as I mentioned, our goal is to partner and work with as many vendors as we can. And here you can see a list of many of the vendors who have joined us on this quest to bring Rocky Linux out to the world in a way that the whole world can leverage this as a stable operating system foundation. And again, focusing on that compatibility, focusing on community, focusing on collaboration and growth. A little bit of interesting information. Our tier 0 mirror, just last month, we had 116,000 downloads of our ISO of the installers. 116,000 downloads just from our tier 0 mirror. If you include all of the tier 1 mirrors, and again, this is a hard number to start putting out there, it's at least double that, a little bit more than double that, which brings us to about 250,000 downloads just last month. And we've checked, and as you probably know, every time somebody downloads the operating system, you got at least one install, probably more. So we're at least, we're estimating at least 250,000 new installs just last month. And we've been tracking between 250,000 to almost 500,000 on the earlier days per month. So the uptake and growth of Rocky is absolutely phenomenal. So yeah, it's really fun to be part of this project. Project is, as I said, completely open. We have a Mattermost, which is a open source alternative to Slack, if you're not familiar. If you go to chat.rockylinux.org, and I do encourage everybody to join if you're interested in Rocky Linux, if you're running Rocky Linux, or just curious about the community, definitely please join. All right, so in terms of future, what are we doing with Rocky Linux? So obviously it goes without saying that one of the areas that we are focused on is that absolute compatibility with upstream enterprise Linux. So that's not going to change, but we are going to build some additional infrastructure around that. We're going to build some additional community around that. The first thing that we're working out is the build system. We started Rocky Linux by using the Koji build system, which is the Red Hat and Fedora build system. And it's been phenomenal in terms of getting us up to speed with something that is as compatible with upstream and Red Hat Enterprise Linux as legally possible. So we've been doing that using Koji. Now, Koji is a static kind of physical cluster type architecture. But Rocky Linux doesn't have any physical hardware. Everything we're doing right now and all of the builds, everything is going up through the cloud. So it is not really actually a very good cloud system. As a matter of fact, we're racking up one massive cloud bill. Luckily, we have so many sponsors and partners that's actually, the money's not a problem at all, but it is a lot of infrastructure to do what it is that we're doing. So we decided to start building a new build system called Peridot. And Peridot is a completely cloud native enterprise Linux build system. It's going to be released very shortly. We're going to be using it exclusively for Rocky Linux version 9. We're already doing test builds, and it does everything from integration with Git and the Git repositories to taking that from Git operations and CI hooks, going all the way through building the operating system, testing each package, and basically signing, doing repository management and whatnot. So Peridot is the tool we're going to be doing that. It orchestrates and manages all of that, and it's easy enough that somebody can install it on their laptop. Moving forward, we've been talking to a lot of people about SIGs, and we've got 3 kind of major SIGs that we're getting quite a bit of movement on. Maybe a little bit less than the last one, but the first two is we're definitely getting movement on. Sig Cloud is an initiative to make sure that enterprise Linux is properly supported on all of the different clouds. And you can see by the list of name drops that we have there, we definitely have a fantastic lineup in terms of organizations that are part of that special interest group. On the kernel side, you may be familiar with Greg KH. He is the maintainer of the stable Linux kernel, and he is actually going to be helping us to build and lead that kernel alternative. So this will be a mainline kernel that you would be able to leverage as an alternative to the standard Rocky EL kernel. And then of course, there's always interest in desktops and better kernels for desktop, better optimizations for laptops, and so on and so forth. I just purchased a new Dell XPS 15, sorry, a little tangent. And I got to say, Rocky installed on it perfectly, even though it's a brand new laptop, and Rocky by definition is a little bit older in terms of kernel support and other features. It is just a beautiful laptop to run Linux on. So, but there are some optimizations that we want to bring into that. So just as a quick example. Additionally, FIPS and other security and compliance accreditations are high on our list. US government, federal, as well as a number of US organizations are asking quite a bit about this. We've seen less uptake of this from other countries, but I'm sure it's going to just help across the board. FIPS is in progress. If you're familiar with doing a FIPS validation, it is a long process and it's expensive process. So we are going through that currently now. And if anyone's interested in that, please do reach out to me. Additionally, documentation. Of course, we always want more documentation. So documentations in our future, as well as vendor support. So as you can see from the previous, or as you saw from the previous slide, there's a lot of vendors that are interested, and all of that is starting to work out in terms of driver support, vendor support, and whatnot. And a lot of these are actually partnering with CIQ, with my company, to ensure that we are offering the best in class support for everybody. And again, that just makes life better for users and consumers, anyone using Rocky Linux. All right, now in terms of focus in HPC, I wanted to talk a little bit about that because, well, this is an HPC group. So first thing is CentOS and Rocky, a lot of people don't know this, actually originally came from HPC people. Not only myself, Rocky McGaw was an HPC systems architect. And first time I met him was at supercomputing. So there's always been an interest in CentOS, in Rocky, and so on and so forth throughout HPC. And as a result of that, CentOS has always had a very large market in HPC. So, if and this is not a scientific guess, but it's a it's a swag. My own approximation is about 75% of the HPC market is running CentOS. And now seeing that CentOS is going end of life, that means, best case scenario, we're hoping to see Rocky track for a fairly aggressive migration strategy and plan. So we are also seeing quite a bit of customer demand. We've been contacted with several IHVs that have requested validation and partnership on support due to RFPs coming in from users. Never underestimate, being a user, being a consumer or a purchaser, how much your wishes actually do affect vendors. If you are interested in Rocky, or you're interested in OpenHPC, or you name your open source project, putting that down in an RFP is one of the best things you can do to help an organization, a open source project, be successful and get uptake with vendors. So please do reach out to your vendors and let them know that you're interested in Rocky or whatever operating system or platform you're interested in. That definitely helps. In terms of Turnkey Solutions, We are also seeing Turnkey Solutions leveraging Rocky as well. So Bright Computing, Open HPC, and my own company, CIQ, which is the founding sponsor and support and services partner of Rocky. We are also offering turnkey HPC solutions, and not only for traditional HPC, but also for something we're calling HPC 2.0. And I'll talk about that here in just a little bit. So in terms of installation and migration, if you've already done any installs of enterprise Linux, any of the enterprise Linux variants, you're going to be right at home with Rocky. Everything is as close to exactly what you would expect as I said before, legally possible. You have the same experience, just with a different paint job. That's pretty much what you're getting with Rocky Linux. Everything just works. So whether you're using the physical install disk, you're using USB media, you're using a provisioning system, again, you're going to expect exactly the same results as you have been expecting with CentOS or any of the other EL variants. We also have a migrate to Rocky tool. You can download that. If you go to rockylinux.org, go to documentation, you will find a link there. You can also go to our GitHub, which is where it exists. And you can find a tool to actually migrate your system from any of the EL variants to Rocky. A migration could literally be as simple as you just want to install or update your repository files for YUM and DNF, or you can use this tool, which will go through and replace all of the packages to guarantee you have gone from running CentOS to Rocky and wholesale. And if you are using configuration management for any aspect of your stack, whatever system that may be, it is a absolute simple drop-in replacement, and everything will work as it's been working with CentOS, with RHEL, with Oracle, with Alma. Anything that you have, they're all compatible. And that's one of the wonderful things about this whole enterprise Linux family of distributions is you all have choices, anything you want to run, and everything is destined to be compatible. All right, so that's the last slide I have on Rocky Linux. So I'm going to go to the next high level presentation, which is on Werewolf. So I'm not sure if everyone here is familiar with Werewolf, but I founded Werewolf in 2001. It is an open source bare metal HPC cluster provisioning subsystem. We are on the 4th major version of Werewolf right now. And a couple of the design tenets of Werewolf are really about it being simple to use, simple to configure, to customize. It's very flexible and extremely scalable. I know usually I'll tell people for about every 1,000 to 1,500 nodes, you can use one Werewolf controller, but you should use multiple if you're going over that. I know multiple HPC centers that are actually around 4,000 compute nodes on a single Werewolf control server and provisioning out the entire infrastructure. So it can scale pretty well. And if you need to go higher than that, you just basically bring up another Werewolf control server and manage your broadcast domains. But if you do that, it can scale, as I said, extremely well. It is the foundation, the provisioning foundation for OpenHPC, if you're familiar with OpenHPC. Lots of contributions and lots of support from many organizations, HPC centers, individuals, and vendors. So it is highly utilized within the HPC ecosystem. And one thing that it's done ever since its initial design was to provision systems statelessly to any number of compute nodes using a template, a file system template that we've called the VNFS, the virtual node file system. And this VNFS has been used since its inception back in 2001. And what's really interesting is that it is basically a container. We were using containers. We just did not know. We didn't know we were using containers. The buzzword didn't exist yet. So now we know it's using containers, and that kind of brings me to some of the goals of Werewolf 4 in terms of where we're bringing it. And one of the biggest things that we're doing is we're making it, from a container perspective, completely OCI compliant, which means you can build your node images exactly as you're building all of your containers and OCI images, and Werewolf will take that and provision that container and blast it out to bare metal to thousands of systems simultaneously, and then boot that system, and then provide a management structure so you can easily manage. You can deal with power management. You can update files. It has a very rudimentary configuration management subsystem built into it, because many of the configurations that you have to put out on compute nodes have to be there before SBIN init is called. So Werewolf does include that, but if you need to do something that's much more complicated, definitely run Ansible on top of that. As I said, it is open source. It has always been community led, and it gives you a very simple way to build up clusters, and you can have different profiles for clusters based on what containers you're bringing in. So you can, for example, bring in an OpenHPC container, and you're building now an OpenHPC cluster. Super easy to deal with. If you want to make changes to that, you can. If you want to build a container that has immediate support for GPUs, as well as InfiniBand, as well as Lustre, you can put that all into the container. You can post that into your OCI registry, either public or private registry, and Werewolf can ingest that OCI container and then again provision that out to all of the compute nodes, including that kernel support. So there's a lot of really cool things you can do. And as I said, it's designed to be easy, but extraordinarily flexible and customizable. All right. Now, many people are familiar with Apptaner, but you may not know it. Apptaner is Singularity. So if you're not familiar with Singularity, Docker kind of brought containers into enterprise. Containers existed before Docker, but Docker is what made enterprises really start leveraging the notion of containers and start maximizing their benefit with containers. We saw, and here in HPC, we saw what containers was doing for the enterprise, but we didn't have a way to easily integrate that. The security model, the usage model of Docker, among other things, was very different to anything to be compatible in an HPC context. So Singularity, I founded about 6 years ago now, and the goal of Singularity was to bring containers into HPC in a way that makes that fits with HPC exactly as you would expect. And it works with all of the traditional schedulers, resource managers, file systems, usage scenarios, and applications. So that was Singularity. Now, Singularity has had quite a journey itself. And one of the things that I really wanted to ensure is that it always remains community. It always remains free and in the community's realm. So one of the things that I did was I started having conversations with the leadership of the Linux Foundation, and it became very clear quickly that the Linux Foundation actually would be a great home for Singularity. And so as we had these conversations and talked about that, they said it's great, everything is absolute positive, but we do need to rename it because there's no way of protecting the name of Singularity or protecting the project if they can't protect the name, and the name can't be protected because it's way too common, it's way too highly utilized. So they asked us to create a new name. We went out to the community and asked for suggestions, and then we voted on those suggestions, and Apptaner was the winner. So Singularity is now Apptaner. And again, just kind of high level view, it is 100%, it is HPC native. It was designed for HPC to bring containers onto HPC systems. It works extremely well at that. Even the file system and the container format that it leverages is highly optimal for parallel and shared storage that a typical HPC cluster is built for. Yeah, not going to go into too much depth here because I'm going to keep moving through this. In terms of future, we're going to be, one of the reasons we wanted to move it to the Linux Foundation was to better bridge the gap between HPC, cloud, enterprise, and hyperscale. And so we're going to be coming in closer to OCI, CNCF, and leveraging and bringing a lot of those capabilities into HPC while bringing HPC capabilities into enterprise. And Apptaner is actually a really good place to do that. So again, bridging that gap. Apptaner also has a really cool way of dealing with things like supply chain security due to how we cryptographically sign and we can even encrypt every single container image that runs. So there's a lot of interest on the enterprise side regarding how we've done supply chain security. Checkpoint restart is something that you can find in the Apptaner 1.0 as an experimental feature. It will be stable in the 1.1, but checkpoint restart exists there. And we're very close to being able to checkpoint GPU apps, by the way. So watch out for that as well. Fully unprivileged support, including the file system support, the CIF support. So if you're not familiar what I'm referring to, just know at some point it'll be able to run completely unprivileged. Integration with PKI, S3 and S3 data import endpoints. Better integration with Kubernetes. Going back to the first point about OCI and CNCF, one of their projects is called Sig Store. We want to better leverage that for the cryptographic signing of all artifacts. And then HPC 2.0. Apptaner and containerization becomes a tremendous on-ramp to looking at next generation high performance computing infrastructures, which brings me to the final portion of this talk, which is HPC 2.0. At a high level, you can kind of think of this as a cloud native, cloud hybrid, federated computing platform. We call our implementation of this fuzzball. And to be clear, to do this, it had to be a complete rethink of the HPC infrastructure. And to kind of describe that a little bit more, the HPC infrastructure that we use pervasively throughout the infrastructure, throughout the entire ecosystem, is all built 100% on an architecture that we've been using now for 28 years called the Werewolf. The Werewolf has been absolutely fantastic and tremendous for giving us the ability to scale these systems, but it is flat and it is monolithic, and it is very difficult to bring in cloud scale, cloud native, and federated type architectures on top of that. We've been able to scale a single Werewolf amazingly large because of the architecture, and the architecture is fantastic for that. But as we start looking at integration with other kinds of enterprise tooling and methods, all of a sudden its architecture definitely shows that it's a bit long in the tooth. So Fuzzball is a complete rethink, a complete redo. If we were to start with HPC again today, thinking of all of the AI use cases, all of the compute and data-driven analytics cases, all of the enterprise-focused cases, alongside all of the simulation, all of the traditional HPC sort of applications, how would we build a single platform to do that entire thing today? And that's what Fuzzball is. And that's what we were actually funded as a company to predominantly go down. We've been working on this for almost 2 years now, and we actually have customers leveraging this. But I'm going to kind of walk through this a little bit and describe how we first started thinking about this. And we first started thinking about this because we had a desire to build a cloud scale hybrid HPC system. Now, us in HPC think, we've been doing things big for quite some time, and we're the masters of scale. We're really not. And I hope I don't hurt anyone's ego, but we're definitely not the masters of scale. Now, we are the masters of pulling it all together and making a single system, a single application perform across a large number of clusters. But when we just talk about giant scale, cloud has us way surpassed us, orders of magnitude surpassed us. So if we were to think about building a cloud scale hybrid HPC system, what would that look like? We had a conversation specifically with one of the biggest hyperscalers in the world, who said that they wanted to be the biggest HPC system, or they felt like they had to be the biggest HPC system to deal with the amount of data analytics that they had to contend with. And so we started talking about this and how would that look? And when we start thinking about building an HPC system and the next generation of HPC system for cloud and hyperscale, they want to build it in terms of units, rack scale units, hyperscalable units, I kind of jokingly call it. And if we were to talk about building a big system, we'd start with one of these. And if we wanted to scale that up, and let's just say we were building a cluster of 100,000 compute nodes, right? So if we were going to scale that up to 100,000 compute nodes, we basically need, and if we look at this basic building block, you can see, there's over 100 compute nodes in it. We got composable resources, GPUs, disaggregated memory, FPGAs, networking, storage, control plane, and so on and so forth, right? So if we wanted to scale that up to 100,000 compute nodes, we're basically building up 1,000 of those racks and distributing those all over the world. And as I continued to learn more about the problem and how we're going to be scaling this and what we need to do to scale this, it became pretty clear this doesn't exist, and it needs to exist, because even if you may not be thinking about this at this scale, there's a lot of capabilities that can be leveraged here for everybody, whether you're in enterprise-focused compute, when you're in traditional simulation-focused compute. We need to be thinking about this. We need to be thinking about how do we solve this? And yes, you can do some of these things sort of on a traditional HPC system with lots of duct tape and shoestring and WD-40, but you can't do it all. And it's kind of gross to do it on top of a traditional HPC system. It's kludgy. So how do we build a system that is designed to do this? So I'm going to start kind of at the top and now work my way down. So if you were to think about building each one of those thousands of HSUs and 1,000 separate clusters in different geographic regions spread all over the world, or in different clouds or different availability zones in clouds, and you wanted to distribute this all over the world, you need to have clusters, some sort of cluster in each one of these, right? Each location, each premise, wherever you're building this, each availability zone, you can have these different clusters. You need some way to first pull these together. And we do that with something called Fuzzball Federate. Now, Fuzzball has three major pieces. Federate is the topmost piece, and I'll talk about the two others on the next slide. So as a user's workflow, some sort of a documentation or a configuration that describes a composable HPC environment comes in via API to Fuzzball Federate. Fuzzball Federate gets to make some really cool decisions that we've honestly never had the ability to really be able to do before in high performance computing. Things like, where do we want this to run based on architecture and resource availability, based on cost, and based on something that we've known for literally decades that we need to be scheduling according to, and we never have, which is data. How do we land this workflow at the right location based on resource and architecture availability, cost, and data? And when we look at data, it's multiple facets. It is data locality, data mobility, data gravity, and data security. And how do we now schedule according to all of these different aspects? And what kind of policies do we need to be thinking that would do that? So for example, if this workflow comes in, excuse me, and it needs some data in S3, well, do we want to run this workflow up in AWS so we don't have to incur the egress cost of that data? Or do we want to move this data to an on-prem cluster where we can now actually cache it possibly, and then manage that cache, and then actually create a breadcrumb trail so subsequent jobs that require that data land in the same spot, right? We get the ability to start thinking about all of this in a much higher level way than we had the ability to do before. So this is Fuzzball Federate. Let's dig in now and look at one of these clusters and what that cluster looks like, because it's a little different from what you'd expect from a Werewolf. In each one of these clusters, we actually have two kind of clusters working together. On the right side, you'll see a compute cluster. This is kind of similar to what we have today, I guess, in a matter of speaking, right? You've got some provisioning. You've got some thin operating system. You don't have to use Werewolf, nor do you have to use Harake, but you do have to run Fuzzball Substrate here. Fuzzball substrate is the base foundation for which all workflows and jobs run on top of. Now, it is a container runtime and virtual machine engine that is operated based on API and leases. So you can make a request to substrate and say, I need 2 GPUs, I need 24 cores, I need this much memory, and so on and so forth. And substrate will say, I can reserve that for you. Here's your lease identifier. And then if you were to want to run any sort of workloads on substrate, you basically just hand it that lease ID and you tell it what you want that lease ID to be able to do, and it will go and do it. Now, if you have, a bunch of these, it makes sense to orchestrate them, to have some sort of system that will actually control them and manage them all in a group. So whether it's 5 systems, whether it's 1,000 systems, right, or 10,000 systems, which is actually our goal to be able to scale up to in terms of substrate, we need to be able to orchestrate to them. Now, the orchestrate side, Fuzzball Orchestrate, is the third piece of Fuzzball. And what Orchestrate allows you to do is it will ingest a workflow using an API, which is the same API that I talked about over here. So from a user perspective, from an application perspective, it's all the same, right? We have the same API, same credential management. It is completely universal. So workflow is going to come in. And when that workflow comes in, Fuzzball is automatically going to manage the ingress of data. It's going to create the appropriate volumes of which jobs, containerized jobs, are going to run. And then it's going to basically push back up egress. In a system like this, there's no need to have home directory storage, but there is a need to have a scratch file system, a working file system across this whole system, in which case we're basically doing the management of volumes and the caching of data. But this data lake becomes really the equivalent of where the home file system was. To run Orchestrate, coming back over here, Orchestrate is a set of microservices. You can see some of the microservices listed here, but this is going to run on top of a microservice engine. So we do like to run it on top of Kubernetes. But Kubernetes, a lot of people are thinking about it from an HPC perspective in terms of running the actual HPC jobs. We've been there, we've done that. We've actually even created a CRI specifically for Singularity to help with this. What we found, Kubernetes is not designed for it. It was a lot of labor, a lot of work to learn that it is not designed for it. Everything from the amount of overhead, the amount of how it handles things like batch scheduling and queuing and whatnot. Yeah, you can add some features into Kubernetes that will help with some of this, but it's always going to be a gigantic kind of subsystem designed for microservices, not designed for batch workflows and high performance compute. And as a result of that, we found that it did not make sense for Kubernetes to be actually sitting on the compute cluster resource. So we keep it confined to the management resource. So if you have, let's say, 1,000 or 2,000 nodes over here, you may want a management cluster of maybe 5 or 7 nodes. But if you're dealing with a cluster of 10,000 compute nodes over here, you're probably going to want a larger management cluster. If you're dealing with a smaller cluster, you can have a smaller management cluster. The management cluster, we've been able to run this on Rancher. OpenShift's still giving us a little bit of some problems, but I'm happy to work on that if somebody's interested with them. Robin.io, VMware. iCube is our own kind of containerized version of Kubernetes that just simplifies the deployment. When we showed this architecture to a number of organizations out there, HPC focused organizations, they basically said, no, please don't make us run Kubernetes. So we basically made it as easy as we could. Now, the workflow, I want to talk a little bit about the workflow now. We talked about this workflow kind of coming into Fuzzball and being able to compose and manage HPC environments. The workflow is basically YAML. We've had one of the big FAQs that we have is, could we integrate with something like Nextflow, or could we integrate with CWL or some other workflow system? I would say that this is workflow, a similar workflow in name only. It is a way that we can compose an environment that we can build from. Now, there's nothing stopping us from fixing and modifying this structure because the whole structure is modular in terms of how it's parsed by Fuzzball. But what we do need to do is we need to identify input datas. We need to identify a pipeline of containers, and we need to identify the output and where that goes. This is a fairly simple workflow, but it does a number of things why we like to use this as an example. We're creating a volume. The volume's ephemeral. We pull in some source data. Here's the egress data that we're going to persist when the job is done. The job is basically an acyclic graph that gives us the ability to have any number of jobs or components or services that run alongside of this. And we can basically, everything is running inside of a Docker container. Could be a Singularity container and any kind of container. But basically this example is running in Docker. We didn't create any of the containers here, but this is a UFS weather model. We create this, and this basically will output the following images wherever you tell it to put it. So again, we need to be able to, what's important is we need data volumes. We need to understand the compute requirements and what the compute pipeline look like, and then resources, GPUs, cores, memory, FPGAs, anything like that. We just need to know what that is. Fuzzball will take the appropriate action and necessary to make sure that this lands on the right hardware. We also have a graphical environment that we're building up right now to manage and build these workflows, as well as create templates based on these workflows. So you can say, make a very, very simple form to for users to fill out that would basically automatically manage one of these templatized workflows and be able to submit that workflow to the Fuzzball cluster. And just basically replacing certain bits to make very easy user-facing applications out of this. But this is an example of our workflow editor in terms of a developer who wants to actually create this and doesn't want to write all that code. Quick example of the CLI. You're going to create a context, which is basically just a cluster. If you're familiar with Kubernetes, this will seem very similar. You can have multiple contexts. You can actually be connecting to multiple fuzzballs. This program is actually running locally. And everything that this program does is over an API. There's no SSH anywhere in the architecture, anywhere in the system. So everything is over API, and all of the APIs are governed by IAM policies. So once you've connected to one, your IAM allowance and policy will define what you're allowed to do on the system. You can basically then start a workflow. You can list the workflow, you can connect to the workflow, you can attach to it. This is really neat for interactive jobs when you attach to it, because you literally are attached to it. You can actually get a container, a shell inside of one of the containers that's running if you need to do some debugging. In terms of the workflows themselves, they support a number of different aspects. This one is a task, shows a task array. Here's MPI. We do all of the wire up for the MPI ourselves. So unlike with Singularity and Apptaner, how you're having a hybrid MPI environment where part is existing outside the container and part is existing inside the container, we do all the wire up. So we actually don't care what version of MPI you're using. It is 100% in the container. Nothing is on the host. So we will do that wire up for you, but that just means we have to know what kind of MPI you're leveraging. We have different types of volumes. This one is a persistent volume, and persistent volumes give the system administrator the ability to kind of manage that data set and say that this persistent volume is associated with this particular resource. Fuzzball will ensure that if any workflows come in, that it lands on that resource, so we can make use of that persistent volume. And again, via IAM policies, you can define if that volume is going to be mounted read-write or read-only to particular users, among other things. We also have an ability to deal with secrets. This is the Nvidia Hpl Ai Benchmark. We actually ran this when we were testing with Nvidia on DGXs. So we actually ran this on a bunch of DGXs. And as you can imagine, it got bare metal speed, just like you would expect. But this script here, as it stands, was enough to basically for us to now start benchmarking systems. And we could have even benchmarked in parallel. Notice that this MPI job, which you can see down here, was just using one node. We can actually increase that to any number of nodes within the DGX pod. Let's see. This one always makes me laugh. Ethereum mining using T-Rex, if anyone's done any Bitcoin mining. This is a demonstration, though, that we can not only use secrets, but we can actually connect to any sort of a registry, both private as well as public. Here's Gromax, Blast. This one's interesting because we're doing custom data movement as part of the job pipeline. This is lamps, but another really interesting thing that we can do, sorry for the Nvidia folks in the room, but we can actually switch where jobs land based on the Nvidia implementation, the GPU implementation that they're running. So if we want to try this on a ROCm system, an AMD ROCm system, we only need to change the container and tell Fuzzball that we're using the AMD GPUs instead. Fuzzball will seek out and make sure that this lands on an AMD system. What this gives us the ability to do is to always drive for optimal TCO for the customers. Some algorithms run better on CUDA, other algorithms run good on ROCm, or have a better TCO on ROCm. So this gives us that ability that we can tune where things land, even on a per job basis within a workflow. Quick example of Jupyter Hub. I know I'm at the top of my time. I should think I'm going a little over, so I apologize. But this is a quick example of Jupyter Hub. Because we're using no SSH in the system, and because of how we've set everything up, everything is going through APIs, even port redirection, even pseudo TTYs. Everything goes through our API. So as a result of that, we can basically spin up a Jupyter notebook. Say we want to run that Jupyter notebook on port 8888. We can isolate the network as part of this workflow. And then when we actually are running this on the CLI on a workstation, we can basically connect and do a port forward from this portion of the workflow back down to localhost. And which means now we can open up a web browser just like you would in like an SSH tunnel on localhost. You can also implement this over a web application and do this completely over a web-based GUI. So a lot of functionality, a lot of features here. You can also do desktop virtualization, among other things. Anything that does do that port forwarding. So long story short, we are really focused on turnkey computing. As I've kind of walked through, we got a number of solutions and pieces of the solutions to build traditional HPC, as well as the next generation of HPC. We are currently in POCs and early beta testing with sites and users. If you are interested in testing any of this, please do reach out to me, let me know. I'd be happy to either do a demo, do additional presentations, or we'll drop a POC in for you if you want to actually play with it. We are expecting to have all of this released GA near the end of Q2 of this year. So things are moving pretty quick. And yeah, that's pretty much all I got. I do see that there's a few questions, although I don't see the questions.
Thank you, Greg.
I'm happy to answer.
Great end note. Yeah, we do have probably about 5 questions here for you. So let's start with the first one, which came about towards the beginning of your presentation. June says, what about SUSE as a partner with or for Rocky Linux? For which purpose would they move to Rocky?
So that's probably the commenter is making note of the fact that I had the SUSE logo as a partner for Rocky. And yes, SUSE has actually been fantastic in terms of supporting this vision, not only on traditional HPC and HPC 2.0, but actually on Rocky as well. Us, just like them, realize that many organizations are comprised of many different operating systems and versions of those operating systems. And we have a very similar idea that, our goal is to empower people, empower organizations, and work with them with what they need. Sometimes that's SUSE, and sometimes that's Rocky, sometimes that's something else. And so we are definitely working with them, and we're very supportive of the relationship there. Also, you saw when I was talking about Fuzzball that there is a necessity for a local Kubernetes cluster to help with the management side of the orchestration resource. And Rancher is a fantastic solution there. So we are partnered on that front as well. And the last thing I'll mention about SUSE is they've been active developers and now contributors in not only what we're doing with Apptaner and now interest in Harake, but also they are actually active developers in Werewolf as well as Apptaner.
Great, thank you. The next question comes from one of our panelists and speakers today, Kenneth. He asks, is it the intention to release Fuzzball as open source eventually, similar to like Werewolf and Apptaner?
So yes, but not similar. So Werewolf and Apptaner were open sourced on day one. The moment I had the idea, one of the first commits into the repository was the license. With Fuzzball, we are not open sourcing it as we're doing this basic development. We are going to be open sourcing it in the future, though, and that is one of our goals. When that's going to be, I don't know exactly, but it will definitely be. It will be open source. I just don't know when yet. Okay.
And speaking about Werewolf, Joseph asks, is Werewolf comparable with HP cluster management utility?
So I can't answer that directly because I'm not very familiar with HP's cluster management solution. I would think that there's probably some alignment and similarities. What Werewolf really focuses on is the provisioning of bare metal and the management of that bare metal. So if that's what HPE's cluster management system is also focused on, or an aspect of it is focused on that, I'd say, yeah, there's definitely some overlap. But Werewolf has been really just focused on that again since day one, and being the base, foundation for provisioning in open HPC. It's gotten a lot of attention and is driving a number of the systems out there. Version 3 was getting a little bit, was showing its age. And just to demonstrate how much age it was showing, you all can mock me if you want. I wrote it in Perl. And we were not getting a huge amount of contributions anymore. It's not that many people like coding in Perl anymore. So the new version, Werewolf 4, is actually all written in Golang. It's written in Golang predominantly to make efficient use of the crossover with OCI and containers.
And then speaking of Apptaner, Jen asked, is Apptaner ideal for normal network multi-tier business applications?
So one of the reasons why the name Apptaner fits so well is because really it is focused on being an application focused container. And I make that delineation consciously, specifically because if you look at what Docker, Podman, and others have really focused on, that is containerization for services, less so for applications. Now, what's the difference? Generally speaking, services are processes that run forever, don't have much load, and in many cases they need to be started as root. Applications don't. Applications usually have a finite runtime. In many cases, especially as we're talking about compute focused workflows and applications, they are going to peg out some portion of the hardware until they bottleneck on that, and they're going to try to run as fast as they possibly can. And typically you're never running them as root. So generally speaking, there's a pretty large delineation, in my mind at least, between containers and runtimes that are focused on services rather than applications. An example of that, another example of that, is with Apptaner, especially when dealing with a high performance computing context. One of the things we don't want to do is isolate. But this is the standard kind of mode of operation for any sort of a service focused container, because that isolation is part of the security story. With Apptaner, that actually complicates the matter, complicates running workloads, running applications. And so we actually isolate as little as possible in order to leverage that container. So let me give an example. When you jump into an Apptaner container, so you're a user when you launch the container. Let's say, if it's me, I'm GMK, it's my UID, my user ID on a Unix system. So when I start up an Apptaner container, I'm GMK inside the container as well. Even more specifically, if I try to obtain root, we have blocked the root pathways in terms of escalation of privilege. So I cannot get root once I'm inside that container, even if I know the root password, even if I have sudo installed, even if I have a root level exploit installed. Little asterisk right there to the security people in the group who may recognize that that can't always be the case. And it's true, it can't always be the case, but so far it's blocked all the root exploits that we've tried. So it's a pretty neat situation, but because I know I'm me inside the container, well, I can do things like, share my home directory inside the container, share the device tree inside the container, share the process table. There's no risk of the process table or leaking outside the container through the proc file system via PIDs. So I can share all of that. I don't have to isolate it. And it gives me a better application experience. One of those, for example, is I can go grab the latest Python container that exists in Docker Hub. I can turn that into an Apptaner container, which is an executable file that sits on the file system. I can put that into my path, and I can actually run my entire Python application against that Python container that exists in my, where the application exists, maybe in my home directory. There's a lot of really cool ways you can play with this because it's, again, focused on applications and not isolating itself and the application away from the base operating system. So I would say a really long-winded way of saying it's not really ideal for network use cases. So if that was the case, I'd say, Docker, Podman, and Kubernetes would probably be a better fit.
And final question, in terms of full package swap, does that mean reinstall all packages in an installed system?
Yeah, it does what's called a distro sync in DNF, which actually will reinstall. So even if you have compatible versions of a package, I'm trying to think of one, let's say OpenSSH, right? There's not much difference between CentOS's OpenSSH and Rocky's OpenSSH, but it will replace the OpenSSH binary packages. So it will do a full reinstall. Now, that replacing will not overwrite configurations. RPM is actually really good at not overwriting configurations. It won't change any of the configs, but it will replace all of the binaries. So if you do want to do a full migration, that will include replacing all of the CentOS bits or whatever enterprise operating system you're running, all of those bits with Rocky bits. So at the end of the day, you are in fact running 100% Rocky Linux. You don't have to do that, by the way. When way back in the day, when CentOS was first coming out, CentOS was founded in about 2003, 2004, because Red Hat end of life Red Hat Linux, which was at the time was their freely available operating system, kind of similar to what just happened with CentOS, but they end of life Red Hat Linux. We had a number of systems at DOE and Berkeley Lab and UC that was running various versions of enterprise Linux or enterprise Linux variants, and we actually, we didn't actually do a full distro sync or reinstallation of all these packages. When we basically just updated the update location for the repos, and just as packages were updated and security fixes were released, we just got those updated packages, and those came from the new source. You could do that. There's low risk in doing that. I've heard somebody say that there might be a breakage in LVM, although I have yet to see that. So it's up to you how much of a migration you want to do. Do you want it to be very non-disruptive, just very simple? So if you have a CentOS 8 system, which is already end of life, and you just want to make it very easy and you don't want to have any downtime, just change your update path. And just change your repositories. Basically, just install the Rocky release package. Make sure your GPG keys are input it into RPM properly, and everything will just work. If you do want to do the full kind of more invasive, more intrusive migration, which will replace all packages and then force a reboot at the end, that's the saner way of running the system, because now you're just running one operating system instead of a Frankenstein between two. But either way will work. It's kind of up to you.
Thank you, Greg. That was the last question. Really appreciate that concluding presentation.
Thank you very much for having me.
Absolutely. Gilad and Hussein, we're now at the end. Any final words?
Gilad, okay, good. But maybe before, if Gregory, you are here, I believe we missed one question that has to do with RISC-V CPU support on Rocky Linux.
Yeah, we have gotten that question now a number of times, and I am absolutely excited at the prospect of doing this. We are going to be tackling this now. We're still working out the details, so I don't know when it's going to happen. But yes, we are working out the details on how to do this, and yeah, we are. I personally am super excited about RISC-V.
Okay, thank you. Okay. Gilad, I spoke a lot in these last 2 days, actually. I'll just leave some space for you.
No, that's why we're doing this, right? So you have an opportunity to speak a lot. That's the reason. So I think we are at the end of the 2 days, and I want to thank again to all the presenters. I want to thank Brian and Sydney for helping with the organization. I want to thank Hussein, who talked a lot in the last 2 days. I want to thank everyone that joined us in today's. I hope that you enjoyed the presentation, enjoyed the content. 2 things. One, if you have any comments regarding content, proposals for future sessions, other topics and so forth, please let us know. Please contact us. You can send an email to info@hpcadvisorycouncil.com, for example, and let us know what you think. I hope that we'll be able to see everyone face to face next year in Lugano. So again, thank you, everyone.